So first of all, we're looking at question number 2 from tutorial number 3. We're trying to use SPSS to analyze the data and answer those particular questions from the tutorial number 3. So here, first of all, I've entered the variables that we have. We had temperature.
Mhm.
All right, we have got density. Okay. We have got density. So all these are numerical values, right? And let's look at the density.
Yes.
I'm sure the density has got how many decimal places, so I have to change the automatic decimal places. Which are, how many decimal places you have?
4.
4. So I've changed the decimal places to what? To 4, so that it fits my data. Then now I can enter my data. Can you give me temperature?
The first one is 0.
Next.
20.
Next.
40.
Next.
60.
Next.
80.
The next.
100.
Next.
That's the last one. Then we move
Okay.
on to density.
Oh, just hold on to the density. So that means we would have to change. If you realize the decimal places for temperature, there is no decimal places, so you can remove that by changing under the variable viewer. Then let's go back to what density. Then if you change, you place 0 decimal places, it will observe what you've done. Then on density,
the first one is 1.
1. Second,
Then 0.997.
97.
Then 0.983. And then 0.983 again. Then 0.973. The last one is 0.9558.
Thank you so much.
There's a typo on the second one. There's only 2 9s. It's
Okay.
0.997. Yes.
Corrected, right?
Yes, sir.
Thank you. So now for us to analyze, now we go under regression, right? And then we choose the one that we want. It's linear regression, all right? Then we select what is our dependent variable, what is our independent variable. I'm sure from the question it's written, right? Our dependent variable it's what? It's density, and our independent variable is what? It's temperature. So density on our dependent, and then temperature. Do you see the window that I'm selecting density and temperature, right?
Yes.
So now we have dragged the temperature and density to respective variable notations, which is dependent and independent. Then probably you go to statistics, right? You select what you want. You want the model fit. The model fit, that will be the regression line, right? You want the estimates you be given. We said you want the confidence intervals, right, of the estimates. We want the R squared, right? So you select what you want. Basically, for the meantime, I think you understand those things. The confidence interval, the R squared, the estimates, right? Then we ask yourself some fun plots. You're going to look at these plots when you're looking at adequate fit of the model, right? You check on this one. What do you need? As we go further, you would need this information so that you'll be able to you'll be able to use. You'll be able to use those functions. All right. So for the meantime, I'm sure we can pick those, and then we understand what we want from there. So let me share the output results, which is in a different window. So in this case, it tells us the variables that we entered is dependent is and ours and our independent variable, right? So we have got the r square, which is 0.930, right? That's what one thing that we want. Then we have got the ANOVA table, the analysis of variance table. We got it. We've got the regression estimates, which is the third table, right? So the first thing that it's on that question is to say find the least squares and write down the equation of the line. So the regression of a line, right? We look at the coefficients table. We've got a column of B, right, which is under unstandardized coefficients. So you see, we have got your B, you've got your standard error. I'm sure if you've checked on how you check the significance of the constant and the significance of the slope, you have to obtain those standard errors. Again, you would have to obtain your test statistic, which is your T, which is in that column T, right? Corresponding to constant, we've got 288.908, and then corresponding to temperature, it's minus 7.301. So these are the values that you usually calculate manually, and you are expected in an exam to know how you compute the estimate, how you compute the standard error, how you compute the T statistic, and also how you compute the confidence intervals, right? I'm sure you've mastered all that. It's very important. So now let's write down the equation of a line. So the equation of a line is to remember it will be y is equals to beta naught plus what beta 1 xi. But in this case, what is our y? Our y is density, right? So in place of y, you write what? Density. Then which is equals to our beta naught, which is our constant or our intercept. In this case, it's 1.003, right? That is what? Our intercept. But now look at something amazing, surprising. There on the slope, it's 0.00. So it's not okay for us to write as 0.00. Probably it's in issue of decimal places. If we change the decimal places, probably you'll get a better a coefficient or a number or a real number, right? Which is not 0. So I suppose we have to change the what? The rounding off from our data. So let's do that. We go to where I entered my data. Suppose let's increase our rounding off on the variable view. Let's say for the temperature, let's increase it and put it at 5. This one, let's put it at 5, and see what happens to the results. All right. Regression, and then linear, and then you click OK. All right. Still, it's not changing. Let me increase because I can see. So let's stop sharing and then show the window with data. Let's try to increase. Probably it may have a difference. Let's put it at 10. Because that slope is too small, right? Then they're saying the number of decimal places is too large. Let's see where we can arrive to. I think it gets up to what? Let me 6. Because they're saying that too large. 6, it's working. Then let's try 7. Let's leave it like it's 7 and see what happens. Still, it's not changing. Let's try it again. A different one. Or this increase to 9. It seems too large. Or probably you can leave it at 0. Let me say 8. 8 is too large. So let's leave it at 0 there and deal with it like that. Because I've tried to change the decimal places. Probably I thought it probably might be issue of decimal places. So now writing our equation, we're going to say y is equals to beta naught, sorry, is density, because we said our dependent variable is density. So in place of y, you say density is equals to beta naught. What is our beta naught? It's a 1.003 plus beta 1. Beta 1, that's the coefficient of what? Of temperature. That is 0, 0.00, and then you say temperature. So the model would be expressed as density is equals to 1.003 plus 0 temperature. So it's just saying it's a constant model or a regression line. Then the other question under that section, it says what? It says construct an over table or the analysis of variance table for the regression model and test the significance of the regression line, which is alpha is equals to 0.005. All right. So let's look at the regression, the analysis of variance. The analysis of variance, the main purpose of analysis of variance is for us to test the significance of that of the regression model, right? So suppose we're given an output, right? Here, the source of variation is for regression, residuals, and the total. You've got the column of sum of squares, right? Which is SSR, sum of squares of regression, sum of squares of error. Error, they're also called residuals, right? So the residuals and the error, it's the same notation, it's same wording that they use. Then DF is for degrees of freedom, and then mean square, it might be mean square for the regression, mean square for what? For residuals, or mean square for the error. Then we've got the F, and then we've got the p-value, which is under sig, which is 0.002. So how do you write the conclusion when you're testing the significance of the regression line? Mainly, you're testing for the slope in this case, which is we're testing for the slope, which is the coefficient of temperature, that is 0.00. So probably you may write the hypothesis or sometimes, but if you know how to write a conclusion, it will be perfect. Suppose you write the hypothesis, you would say H naught, which is your now hypothesis, beta 1, right, is equals to 0, and the alternate hypothesis, which is H1, beta 1, it's not equal to 0. Then the rejection criteria, we are saying we reject H naught if the p-value is less than 0.05. Right. So what is our p-value in this case? It is 0.002. Right. So are we going to reject H naught? Yes, we are going to reject H naught since the p-value is less than 0.005. Right. We reject H naught. So when you're rejecting H naught, what are we considering? We're considering that we're considering the alternate hypothesis, that is H1 beta 1 is not equal to 0. So when you're saying beta 1 is not equal to 0, what do you imply? Imply that it's statistically significant at 5% level of significance. So this is how you comment on you just say since the p-value is equals to 0.002, it's less than what? 0.05, we reject H naught and conclude that the regression line is statistically significant at 5% level of significance, full stop. That's how you make a conclusion. But if you're doing it manually, you have to write all the steps. You have to write H naught, H1, right? You have to write the level of significance. You have to write it will be what? It will be an F test, right? So you're comparing this F test with the one tabulated with the 1 and 4 as your degrees of freedom. You have to write the regression criteria based on the manual approach. All right. Then the other question says calculate the 95% confidence interval for the slope in the line. So you can make decision based on the what? On the confidence interval for testing the significance of the slope and testing for the significance of the what? Of the intercept. So usually we say we expect 0 to be an element of what? Of the interval, right? So if 0 is an element of the interval, we are saying it's what? It's statistically significant, right? So we look at the first one, right, which is 0.993 and 1.013, right? So does it contain, the first question, does it contain 0, that interval? That interval doesn't contain 0, right? And then the second interval, does it contain 0? Approximately, yes, it contains 0 because there's a 0 there, so which is significant. So you can make conclusions based on the confidence interval. You can make a conclusion based on the significance. You can make conclusion based on the t-value, which you compare with what? The critical value. Sorry, I can remove those people who didn't mute their mics, and that'll be it. Because if you don't mute your mic, we're going to remove you from the lecture. Because every time when you join, guys, please mute your mic, so that I think those who have joined, they realize I was muting my mic. So we have got the confidence what? Interval. So you need to make conclusions based on the confidence what? Interval. And then what is another question on that tutorial? It says calculate the coefficient of determination and interpret it. So we've got this coefficient of determination, which is around 0.930. So you're saying one, there are two ways of interpreting that. So one, you have to look at the percentage. You express that as a percentage, which is 93%. What it tells us that the model is performing good, right? It's a good model for what? For prediction. The other explanation is that the model accounts for 93% that is explained by variation in what? In the independent variable, the variation which is caused by what? By temperature. So we're saying the model accounts for 93% or explained by the variation in the what? In the independent variable. In this independent variable, we're looking at what? At temperature. So basically, that's it for simple linear what? Simple linear regression model. So you need to be able to interpret the R squared, right? You need also to be able to interpret the p-value of the ANOVA table. You need to be able to interpret the p-values of the coefficients table, and you should be able to use the confidence interval to test the significance of the what? Of the coefficients. So basically, that's it about simple linear regression. And on Wednesday, we're going to focus on multiple linear regression in SPSS. So any questions about simple linear regression on this particular question? So if you've got any question, you can send it on the chat, or you can unmute your mic, and then I hear your question so that we discuss.
Sir.
Yes, go ahead.
All right. I have a question on conclusions. That is when we test for the equation, when we test the regression model, right? There's an issue of there being enough evidence to reject H0 or not enough evidence to reject H0. How exactly are we supposed to word that if we're going to use the evidence issue?
Okay, it's excellent. Okay, I'm sure you guys, do you know what's type 1 and type 2 error? Hello?
Yes, sir. Yes,
You know
sir.
what's type 1 error?
Type 1 error is accepting H note when it is false.
We don't want to use that term, accept. We avoid using.
Failing to reject H note when it is in fact false.
Isn't it that type is type 2? Isn't that it's type 2? Well, the type 1 error is when you reject H naught when it is true. I think you vice first.
Yes, yes, sir. Yes.
So we are looking at those type 1 errors and type 2 errors. So usually we give a level of confidence. All right. Yeah, we are left with 10 minutes. I'm sure your questions will be answered in this session. So we avoid such a situation where we have got type 1 and type 2 error. That's why we give the level of significance. So if I'm giving a level of significance of 5%, I'm sure, I'm 95% sure about my results, right? If I give a level of significance of 1%, I'm 99% sure about what? My results, right? So suppose our H naught is, in this case, on the regression, right? In this case, if you're testing for the significance of the regression, we are testing for the significance of the slope, right? So the slope is what? It's beta 1. So we are going to say H naught is equals to H naught beta 1 is equals to 0, which means we are saying it's insignificant, right? Then H1 we're saying H1 we're saying beta 1 is not equal to 0. Then we reject H naught if the p value is less than what? 0.05, right? So in this case, right, we have got 0.02, right? So we are saying it is, since our p value is 0.02, which is less than what? 0.05. We reject H naught. So when you're rejecting H naught, what do you mean? There is no, or there is no sufficient evidence to suggest that the simple linear regression model is insignificant. What we are saying, we don't have sufficient information to prove the null hypothesis. We only use there is no sufficient evidence. We don't say there is sufficient evidence. We use there is no sufficient what? Evidence that suggests that the simple linear regression model is insignificant. That's why we rejected it, right? So we'll be trying to avoid the aspects of type 1 and type 2 error. So we would say we reject H naught, right? And then we conclude that we have no sufficient evidence that suggests that the simple linear regression model is what? Is insignificant. That's why we had to what? To reject it. I'm sure, are you getting it?
Yes, sir, I'm answered. Thank you.
Yeah, we don't use sufficient. We use there is no sufficient. We don't have that enough evidence to conclude that the simple linear regression model is what? Is insignificant. But rather, we'll say we have rejected H naught, and then we have no sufficient evidence to what? To say it's insignificant. Never use the word accept, because we are not 100% sure about it. So we're 95% sure about our results.
Yes, thank you, sir.
You're welcome. Any other questions, guys? We are left with 7 minutes. It seems this was so simple to you guys. Probably you've done it. Some of you have done it. It's excellent if you've done it. I hope all the guys in this class are doing this practice work. So we can stop the meeting, and then those who are joining for ARA, we can meet at 3. Tifa is saying SPSS exam how? I'll give you, look at tutorial. Let me share you tutorial number. Okay, what I can give you, and I'll give you this output, Tifa, all right? And then I say, write down the equation of the regression line, all right? That will be obvious, the question, right? Probably another question would be, say, test the significance of the slope. So when you're testing the significance of the slope, you're going to use the p-value, or you're going to use the confidence interval. But if you're going to use the t-value, that would be a long approach for you, right? It's better use the p-value in the significance value. I may decide to remove one of the standard errors and say find standard error, because you have got the intercept and the t-value, right? So it's a matter of making what you call standard error the subject of the formula. So what you need to know is the relationship between these values in each and every table. On the ANOVA table, I may decide to remove the total, right? The sum of squares of the total. I may remove one of the degrees of freedom. So find a relationship of how you can compute these values. I may say interpret the significance of the regression model. You should be knowing what value to pick from which table. If I say comment on the coefficient of determination, I have said it in any expression, comment on the coefficient of determination. You're supposed to know where to pick the coefficient of determination. Coefficient of determination, that's R squared, which is 0.93. Then you have to comment on that. So try to play around with the relationship with the values that are in this table. I think one of the tests you're going to write a test based on the outputs, because it will be there in the exam. That's why I said SPSS is compulsory.
Yeah, thanks.
You're welcome. Suppose I remove that F value, right? I'm expecting to be able to see you being able to calculate that F value from the ANOVA table. Any other questions? If there are no questions, we call it a day. Have a good time if you're not joining us on the SPSS part.